14th, the earthquake ceased abruptly as the summit eruption started from a half-mile-long line of fissures halfway up the south wall of the 650-foot deep crater Kilauea. Within an hour after the outbreak, cameras were set up about a mile away to obtain these photographs of lava fountains spurting to heights of 50 feet. They feed a number of braided lava streams that pour down more than 300 feet to the bottom of the crater, where they coalesce and begin to spread across the floor. The flat, 37-acre floor of the crater, formed by lava extruded in 1868, is rapidly covered by the new lava. Sparkles of light dancing over the lava are burning trees carried along by the flows. As they move across the floor, they break through their own cooler margins, forming lobes. During the next 2 hours, the fountains increase to 100 feet high along the entire half-mile line of fissures in the crater wall. These lavas contain less than 50% silica and cool to form what are called tholeite basalts. The hottest lava is bright yellow-orange. As its surface cools, it becomes dark red, although it's still very hot inside. By 10:30 p.m., fountaining declines at the outermost vents, but they continue to glow, and many emit gases that burn with pale yellow-blue flames. Large bubbles of rising gas in the vents cause vigorous splashing of the lava over the edges. Before sunrise, the main fountain is 100 feet high and looms above trees that have been stripped by heavy masses of lava spatter falling through them. At sunrise, only 2 fountains remain. Lava from them flows down the narrow trough in the west end of the crater, cascades over a steep bank, and on into the deeper part of the crater to the left. The main fountain builds itself a small spatter rampart. Still later in the morning, the lava lake has spread to the forested slopes. During the extrusion of lava, seismographs in the vicinity record an unusual type of motion of the ground called harmonic tremor. Scientists of the Geological Survey's Hawaiian Volcano Observatory prepare to collect gas and lava samples at the base of the fountain, now only 200 feet away. Sulfur dioxide fumes and intense heat radiation make such sampling difficult, but these samples aid in interpreting the origin of the magma and the mechanism of the eruption. They may help also in understanding the origin of the atmosphere in the ocean, as vast quantities of such gases have been given off by countless volcanoes over the long span of geologic time. Lava rivers flow down the steep slope, with one on the right flowing along the former Kilauea Trail. Through the second day, more and more lava pours from the one remaining fountain. Sudden fluctuations in the output often cause the entire cascade leading into the deep part of the crater to be awash with lava as it flows down the slope and under the crust in the ever-deepening lake. On a fairly steep slope, the lava forms vigorous rapids over irregularities in the channel, breaking apart floating pieces of cooler crust. Although flowing like water, this lava actually is a highly viscous fluid. Here, the lava plunges over a steep cliff, forming a lava falls. On a smooth slope, the lava river appears as a bright, incandescent ribbon flowing at speeds up to 20 miles an hour. The flow is fastest in narrow channels. Where the channel widens, pooling of lava occurs. The river of lava winds down the valley through natural levees of its own making. It splits and recombines around barriers, much like water in braided river courses. As the stream pours into the rising lava lake, it flows under the chilled but still flexible crust, floating it upwards. The fountain continued through the night, sometimes suddenly showering new portions of the crater slopes. Through the first 6 days of activity, the fountain has continued to grow to more than 10 times the height of Niagara Falls. It forms very strong air currents and more pumice and cinder, which the prevailing trade winds blow to the lee of the vent, building up a large pumice and cinder cone on the crater rim. By the end of the eruption, the top of this cone will be 400 feet above the level of the vent. Viewed from the southwest during a temporary lull, the cone obscures the eruption, and only fume clouds can be seen in the background. Seen from the air at late sunset, the massive orange 800-foot fountain sends hundreds of thousands of cubic yards of lava per hour into the rapidly filling lake. Here, just prior to the end of the first phase of the Kilauea eruption, the fountain shoots 1,000 feet above the surface of the lake. Although this appears to be an exceedingly violent eruption, geologists actually consider Kilauea to be one of the least violent active volcanoes on Earth, and hence most suitable for close study. Obstructions in the vent may suddenly divert the jet, causing devastation of large areas surrounding it.